solving a literal equation, you're solving it for one letter, but it's got many letters in it. But you're still going to do it the same way that you would a regular equation. So if I have something that looks like area is equal to base times height, and it says solve this for the base, then what you want to do is you want to undo what's been done to that letter that they're telling you. So this says b times h, and to get rid of a times, we would divide. So I'm going to divide both sides by h. It's going to cancel over here. So I'm left with b on this side, and I'm left with a over h. Okay, so my final answer would be b is equal to the area divided by the height. Now, they don't always make sense like areas base times height. Sometimes they just give you some random numbers. Let's try something like that. So let's do 3a plus 4b equals c times d. And we're going to solve this one for b. All right. So if I'm going to do this for b, I got to get all this other junk that's over there on that side with it away. So how am I going to take this 3a and move it over here? It's a positive 3a. I don't want to divide here because I've got a 3 and an a. If I divide by 3, my a still stays. That's right. I don't want to do that. I want to subtract. I want the whole thing to move across the equal sign, so I'm going to subtract it. So I'm going to subtract 3a from both sides. Just remember, you can't put these together because they're not alike. Remember, to be like terms, to be able to add or subtract them, they got to be the same letters to the same exponent. So if it's an x and an x, I can put it together as a 2x. If it's an x squared and an x, I can't put it together, they're not even to the same exponent. All right, so on this side, what I'm left with is 4b is equal to cd minus 3a, and just leave it like that. And then I'm trying to solve it for b. What's beside the b is a 4. That's a multiply. So to undo a multiply, I divide. Now I just have to divide this whole side by 4 over here. So I have that b is equal to cd minus 3a over 4. And that's the answer for b. And that's how you do literal equations. They can be more complicated than that, or they can be a lot less complicated. I could give you something simple like this. If I have x over c is equal to p, and I say solve this for x. Okay, this is the divide. So how do I get rid of a divide? Multiply. So the c's are going to cancel out, and you'll have x is equal to p times c. That's a much more simple version. Same problem, x over c is equal to p. What if they tell me to solve it for c? And that's a little bit more difficult because c is in the bottom of the fraction. So the very first thing I'm going to do is get it out of the bottom of the fraction. So I'm going to multiply by c, and we'll start it the same way I would the other one. So now I have x is equal to p times c. This is a multiply, so to get rid of it, I divide. So x over p is equal to c. Okay. And that is literal equations. That was last Thursday's work. And I think I actually gave it to you a couple of days last week, maybe on Wednesday and on Thursday. You don't have to do every problem on every worksheet, but you do need to do it and practice it and let me know, if you're having difficulties with it. I did give you the answers so that you would know whether or not you did it correct. So use those to kind of guide yourself there. All right, last Friday we started inequalities, and inequality is solved just like an equation, with the exception if I multiply or divide by a negative number, my inequality sign has to flip. So let's just start one. We'll do one first that's not dividing by a negative, so you know what I'm talking about. If I have 2x plus 3 is greater than 11. If this were an equal sign here, what would I do first? How do I solve for x? Minus 3 from both sides. So I have 2x is greater than 8. And then how do I get rid of a 2 times x? Divide by 2. And 8 divided by 2 is 4. So that would be my answer. Now, when you're doing inequalities, you can write the answer like this. You can also graph the answer. So if that's 4, which numbers are greater than 4? I would start at 4 and I would go this way. Now, remember, it's an open circle because greater than, let me write that again. Greater than and less than get open circles. Greater than, equal to, less than, or equal to get filled in circles, meaning that number is included in the answer. This means it's starting there, but that number is not included. So it's starting at 4, but 4 is not actually included in the answer because 4 is not bigger than 4. But anything bigger than 4, like 4.01, will be greater than 4. So it would be included. 4 is your starting point, it's just not included itself. Okay, but if you go back to day 2, we talked about interval notation, and that's when you were reading the graphs from left to right. So the first thing that I come to this graph when I'm reading it left to right is the number 4. Remember that the parenthesis versus the bracket is the same as the circle being open or closed. These get a parenthesis, these get a bracket, meaning they've been included. So this one's not included, it would be a parenthesis. And what is the last thing over here that's shaded? Well, there isn't anything last, right? It's called infinity, and infinity always gets a parenthesis. So you can actually give me your answer 3 separate ways here. You've got x is greater than 4, you got x is greater than 4 in graph, and you got what would be graph would be 4 all the way to positive infinity. Now, let's talk about how these are different from an equation, because all this was exactly the same. The only thing that changes in a regular inequality is if I happen to multiply or divide by a negative number. Right, so if I have x over negative 3 plus 2 is less than or equal to 5. Right, I start out the same way, okay? I need to get rid of this plus 2 first by doing a minus 2 on both sides. So I have x over negative 3 is less than or equal to 5 minus 2 is 3. This means divide. The opposite of divide is multiply. So I'm going to multiply by a negative 3. Now when I write that down, in my mind, I think, oh, I just multiplied by a negative, so this sign has to flip around. So it's no longer going to be a less than or equal to, it has to flip to a greater than or equal to. If it were greater than or equal to, it would flip to a less than or equal to. If it doesn't have the bar, then when you flip it, it doesn't get the bar, okay? It stays. It just flips from greater to less or less to greater. But it cancels out over here, so I have an x, it's greater than or equal to 3 times negative 3 is negative 9. Okay? Now, if you want to see why that happens, why you need to flip it around, I can show you that. You just need to let me know later. But basically, 3 times negative 3 is negative 9, so my answers that work will be values of x that are greater than or equal to negative 9. So if I'm on a number line, remember negative goes this way. So this will be negative 7, negative 8, negative 9, negative 10. But greater than or equal to would be a filled in circle there going this direction. So in interval notation, the first thing that's graphed is negative 9. It has the filled in circle, so it gets a bracket. And then it goes all the way up to positive infinity. And it's a parenthesis for that, as always. Now, today's work is on compound inequalities. So this is when you actually have 2 inequalities that are joined together, okay? 2 of them that are going to be joined together. Sometimes they're joined by the word and. Usually, though, if it's joined by and, they'll just kind of smash them together and it looks like 3 pieces. They'll have like 4 is less than x is less than 7 or something like that, okay? And they'll have 3 different parts to solve. And then there's also an or, okay? When you graph, when you're graphing these, if I say to you, I want the wipes and the mask on the desk, the wipes and the mask, that does not make me happy because only one of them is there. That does not make me happy because only one of them is there. If I say and, I'm looking for both of those things to be on the table, right? So in our graphs, we're going to end up with 2 answers. And what you're going to be looking for is the overlap. One's going to go this direction, one's going to go this direction. And where there's overlap, where both things happen, that's going to be my final answer. If it's an or, if I said I want the whites or the mask, okay, then I'm happy here. I'm happy if that happens, and I'm happy if both of them happen to be on there, right? So an or sometimes will look like this. You'll have one going in this direction, and then another one on another place going in the other direction, okay? It looks a little weird. There's no overlap there. If it's an or and there happens to be overlap, it just means the whole line is the answer, okay? But usually there will be a gap in the middle that's not covered, okay? All right, so let's work through a couple of these. So if I have, let's see, -5 is less than x plus 3 is less than 7. This is an and. I know that because the word or is nowhere to be found, and they're smushed together. It's got 3 parts to it, 1, 2, 3. I'm going to solve this just like I would an equation or an inequality. I'm just going to pretend this side's not here. How do I get rid of a plus 3? I do a minus 3 here and here. Well, now just do it over here too. You just have 3 places to do it, okay? Cancels out here. So a -5 and a -3 add to be a -8 is less than x is less than 7 minus 3 is 4. So now I'm ready to graph it. I put my 2 numbers I'm dealing with on the number line. So, and then I always start above that graph. So I'm going to do this one in green. Okay? Except I don't like to graph it with my x on the wrong side. So I'm going to flip this part around. If -8 is less than x, that means x has to be bigger than -8. -8 is smaller, so that means x is bigger. So it would go this direction. X is less than 4 would start at 4, and it would go this direction. This is an and, so I'm looking for that overlap part. So the overlap happens right here. My final answer for this one would be like this. It's an open circle at -8, an open circle at 4, and I'm shading the stuff in the middle. Okay? If it's an or problem, you just work it as 2 separate problems. So I'm going to have, let's say something like 3x plus 2 is greater than 14, or x minus 1 is less than -3. So I'm going to solve it as 2 problems. Subtract 2 from both sides. 3x is greater than 12. Divide by 3. X is greater than 4. Okay, here I would add 1 to both sides. So I'd have x is, less than, -3 plus 1 is -2. So when I graph these, here's 4, here's -2. X is greater than 4 goes this way, less than -2 goes this way. So they go in opposite directions. That's what I'm going to graph. Okay. All right. Now the last thing is for